All right, this presentation will go through how to complete the lab for the alpha decay, the PhET lab. You can download the lab if you want to from the link and run it by yourself. That's perfectly fine, but I know a lot of you won't have the computers able to do that because I think it's only certain PCs that are able to actually download it and do it. And some of you are probably using your phones or something like that. So I'll just go through it. I'll show you, kind of run through it. You can rewatch the video or the portions that you need to kind of get the information you need, and I'll kind of point out where to put everything, and you just complete it and turn it in. By the way, I don't really just love Starbucks, but my wife painted that. She's a very talented painter. She also painted that, but we'll get to it now. So you should be looking at this page. It says explain the alpha decay process, complete radioactive decay equations, define and analyze half-life. So we've already talked about alpha decay, and so this is going to be a review of that. We've briefly talked about half-life. We didn't actually really get to go into it very much, so this will kind of go through what exactly half-life is if you weren't able to finish those labs that we were doing in class right before spring break. So you, like I said, you could click on that link and run the alpha decay one if you want to, or just watch this video. So we're going to start with a single atom tab. We're going to observe the decay of polonium-211, and after each decay, press the reset nucleus button to watch the process again, and just write a description of alpha decay. Okay, so I'm going to run through it a couple times here so you can see what it looks like. So we're going to reset and press play here. So you can see, if you look right here, there's a bunch of little particles moving around. We know those as protons and neutrons in the nucleus here. And then eventually one's going to shoot off, and it's going to go from yellow to black. And notice now it is lead Pb207 instead. So something shot off there. And because we're doing alpha decay, we know that as an alpha particle. Okay, so I'll reset it again. All right. You can see down here, this we're really not going to get into. This is actually specifically what is actually happening due to the energies of it. But don't focus too much on this, but you can kind of see that they're kind of stuck in between this potential energy bars here. And once that total energy goes below the potential energy, it shoots off. So I'm going to reset it again. You can see up here how long it's taking. And there's this red line called the half-life that we're going to be talking about. So I'll run it a couple times. So notice this one is going much, much past the half-life. Still polonium-211. And let's see. And it's still going off the page. Wow. There it goes. It finally did it at 3.9 seconds. So you can see that the half-life doesn't determine necessarily exactly when it decays, but we'll get into that as we go through this page here. But you can see that certain ones decay at certain different times. Okay, so we'll go back to the paper here. So you should describe what is actually happening for alpha decay. You might need to look it up if you need to. All right, complete the following alpha decay equations using ptable.com. as a resource. So these actually should be familiar. Again, this is just practice for what we've been doing in class. So let's just do the first one here. So 211, 84 polonium turns into 207 lead 82. And what's going to shoot off is, well, it lost 4 up top. So here's how you're going to kind of write it. You could either, oh, by the way, you could either write this on a piece of paper and just take a picture and upload it. That's perfectly fine. Or if you want to try typing it in, you can do that as well. So 4 up top, and we're going to do slash. Looks like it lost 2 on bottom, and that would be an alpha particle or He nucleus. You could also write alpha if you wanted to, like an A. That's fine. Means the same thing there. So notice that actually looks like this number and alpha particle over here. Okay, so was that radium? Let's go back over here. So if you use this P table, it's just a periodic table from online. So we're looking for Ra, radium here, 88. The top number is going to go down by 4. Okay, so let me just kind of get rid of this here. So the top number is going to go down by 4, so it's going to be 222. The bottom number is going to go down by 2, so it's going to be at 86. Well, now we go back on our periodic table. It's going to go lose 1, 2, and turn into radon, Rn. So we're going to capitalize the Rn like that. And that would be kind of another way to show that that's what it's turning into. Okay, you should be able to do the rest of them yourself. Again, you can type them in there just like I did, or write them on a piece of paper and take a picture and upload that. Okay, how's alpha decay used in everyday life? Well, I've actually given you an example of that already, but you should be able to look up more ways on Google. Okay, number 8, investigating half-life. So now we're going to kind of do a little lab with the simulation. The simulation is a fairly accurate simulation of what can happen in real life using the correct math and numbers. So it says, click on the multiple atoms tab, execute 5 trials to determine the number of parent and daughter nuclei at 1 half-life. Complete the table below. So we're looking for, after 1 half-life, what is the parent and daughter nuclei? Parent meaning what's left over that hasn't decayed, daughter being what has already decayed, and that will be yellow and black respective in this specific simulation. So first I'm going to start out with 20 atoms. So I'm going to go to multiple atoms over here. Going to reset everything. I'm going to reset all here because I have too many atoms. So it said that they're going to be 20, so that's 10, 20. I'm going to click play, and I'm going to pause it at the half-life once the whole thing reaches the half-life. All right, so notice up top here, the clump, the leftover stuff, has reached the half-life. It's been about 0.52 seconds. We can see here that the yellow, the remaining, are 14 parent. So we go over here, and we click 14. Everything left over is black or decayed. So everything that has decayed is black. So that'd be 6. So you can see here only about 30% or so have actually decayed after 1 half-life. Okay, I'm going to now do 40, so I'm going to reset all the nuclei. I'm going to add 20 more, so it's 40, and I'm going to click play. Great, so you can see a lot more stuff is happening now that there are 40 of them. I'm going to pause it at the half-life. So here, 13 and 27. So 13 yellow, 27 black. So 13 yellow, 27 black. Notice now about 66% or so, 2/3 have decayed. So it's half-life kind of makes you think about half of it should have decayed. So obviously this is a simulation, so it's not going to be perfect. But now we're going to do the same thing with 60 molecules. So reset. We're going to add 20 more to be 60, and we're going to hit play. And stop. And half-life, here we go. So 31 yellow, 29 black. So you do 31, 29 here. All right, now we're gonna reset and add 20 more, so we have 80. And press play. Okay, pause it. 36 and 44, so 36 and 44. You're gonna go down, add 20 more, and reset all of them. Press play again. Pause. 50 and 49. Look, as we add more, it gets more and more accurate as to what a half-life is here. So 50 and 49 are going to go there. I'm going to let this run all the way through so you can see what happens as it goes through. Now remember, this is just a simulation, so in real life there are billions and billions of atoms in everything, and you can see slowly over time there it kind of decays slowly over time. So it seems like it decays really quick right away. So this would be like one object, one piece of polonium as it decays into lead over time. All right, looks like only 99 showed up instead of 100. I don't know where that 100th went. All right, so that's that. Now we can define half-life. You can use your own words here, or you can kind of paraphrase a definition from online. First, I would like actually for you to try it on your own, and then I would look it up. All right, now, suppose a substance has a half-life of 0.52 seconds. That's actually polonium does have a half-life of 0.52 seconds. That's what this is. Create an accurate pie chart showing the number of remaining parent nuclei and decayed daughter nuclei, shade slightly, starting with 40 total nuclei. This is going to be very hard to do on the computer. I recommend, again, drawing it out, taking a picture, and maybe just inserting the picture in there, or just do all of it on the paper and then insert your picture. So prediction. So after one half-life, we expect half of that to be left over. Here's one way you could do it. I'm going to insert a drawing. Let's see, pie chart here. Ooh, a pie. I wonder what that, no, that's just Pac-Man. Oh, we can move it. Oh, see, that's very helpful. All right, so we said half to be left over. That's what half-life is. So after one half-life, we expect half of it. So I can just click save and close, and it'll pop it in there, and I'll kind of have to adjust things to make it look pretty. All right, now after 1.04 seconds, that's twice the time. So that would be one more half-life has gone by. So we expect half of that stuff to decay. So instead of half, we'd expect half of 50%, which is 25%. So I'm going to insert a drawing. I'll go up here and do a pie again. I'll draw it out. Okay, and then I said half of a half. I expect only 25%, 1/4 of it to be left over. Save and close. I'll put it in there. I'll shrink it so it matches. Maybe I'd love to move it over. Oops. Look at that. Well, maybe you should put some spaces in there because I can't get the space in there now. So do like this, and then that way you can kind of spread them out on your own. All right, so then as you see, 1.56 would be one more half-life. So we'd expect, instead of 25%, we'd expect half of that 25%. And then finally down here, we'd expect half of that half, so that would be half of 12.5. And we get about 6.25. 6.175. All right, so you should be able to finish those off. Now it says simulation with actual values. So we're actually going to do it starting with 40 nuclei, and we're going to do, after 0.52 seconds, we're going to see how much is left, what the pie chart looks like. So we'll go back over here, we'll reset everything. Let's see what it's, okay, so I'm going to add 10, 20, 30, 40. Press play. Doesn't look like it's working here. So I'm going to reset all of them. How many does it have? All right, so it only has 25. Let's try this again. So it's 30, so I'm going to add 10 more. let me go over here and see if all right. This is not liking me. All right, I'm gonna close out of this and hopefully restart it. All right, so 10, 20, 30, 40. All right, so it's already starting to go, so let's wait. So one half-life we said was 0.52 seconds, so right there. Okay, so you can see we would actually create a pie chart that had half of it left over. Okay, they're showing the top half, but you know what it means, right? The yellow part is the shaded part there. Okay, I'll wait till about 1.04 seconds. Right about there. Okay, now you can see that about 25% is left, so it's pretty close to what we actually expect here. Now I'm gonna wait till 1.56 seconds. Out there. All right, so it'd be 12.5% or so. Actually, we can actually do the math here. So if you divide the number left, so 4, divided by the total, which was 40, it equals times 100, and we get 10%. So instead of 12.5, it's 10%, but it's pretty close for this kind of simulation. Now we're going to wait till 2.08 seconds for the last little part here. Stop right there. Okay, so we have 2 left. So 2 divided by 40 is 0.05 times 100. So that's 5% left, which is pretty close to our 6% that we were expecting here. All right. So I'm going to draw those in here. So again, I would just probably space, and then I would insert my drawings of what you can pause the video and kind of insert your drawings according to what I was just showing you at those each individual times there. Now it says, how does your prediction match with the results of the simulation? Convey with actual values. So I showed you how to do the actual values. You divide what you have left over, 2 here in this case, divided by the total, which is 40, and then multiply by 100, and that gives you a percentage. And so those are, like I said, we're actually pretty close to what the values showed up here. So hopefully you're able to do that, and then you can just write out an explanation there. Right now, it wants you to do 3 trials and complete the table below. So we're going to do the number of decayed daughter nuclei, so the black ones, after each of these times, trial 1, 2, and 3, and then you can average them out. So I'll show you how to do that for one of them. So here we go. We'll reset all nuclei. We'll press play. So we'll wait till 1 half-life has gone. There. So 16 daughter nuclei. So I've been shading the parent nuclei, what's left. So let's just actually do that instead. So we'll do the number of parent nuclei left, because that's what we've been doing so far. So in here, it looks like I have 24 parent nuclei left. Okay, so I'll wait till 1.04 seconds. About there. Looks like I have 12 left, so I'd write in here and I'd write 12. I'm going to do 1.56 about there. 6 left. So I go in here and I write after 1.56 seconds, there's 6 left. Now I got to go to about 2. Maybe about there. 5 left. Oh, only 1 decayed. And then finally 2.6 seconds. About there, 2 left. All right, so I'm gonna do that 2 more trials. So reset. There. Again, 16 left over. So I'd go in here, I'd write 16. All right, now I'll go to 1 second. There. 8. I'll go to 1.56 seconds. 3 are left over. 2 seconds. All right, well, at 2 and 2.6, they're both going to be 0. So when we're doing this, both of these will be 0 because all of them decayed. All right, we'll reset and do that one more time for our 3rd trial. There, 17 left over. That'll be trial 3 here. Okay, about 1 second there. 8 left over. All right, 1.56 seconds there. 5 are left over. Okay, about 2.08 seconds. 4 are left over. All right, and then only 1 is left over after 2.6 seconds. All right. Now it says to share and discuss one aspect of your table with another student in class by commenting on the question on Google Classroom. So I'll kind of paste this into Google Classroom, this question here, and I just want you to make a comment on your table and kind of what does it mean to you? What are you trying to show here? Averages, by the way, you just add up these 3 numbers and then divide by 3, and that'll give you your average. So add up these 3, divide by 3, that gives you your average. Add up those numbers, divide by 3, there's your in there. Okay, so finally, we're just going to use our Google Sheets to make a graph of average decays versus time, including, we're not going to use error bars. All right. So we are only taking our average here. So what I would do is, let's just put in, I'm going to pretend that our numbers here are 25, 12, 6, 5, 2 is our average. So I'm going to take these numbers, I'm going to copy them, Control C, or copy them, go up here and type in sheets.google.com. I'm going to add a blank one. I'm going to click in this A1 box here and click Control V, or I can paste the values. Okay, now it's going to put my my data table in here. What I can do is I can highlight the data. I'm going to click and hold and drag until I highlight my data. You would what you would do is, let's pretend these numbers were in here in our average column. What I would do is I would just take these, highlight them, and drag them over here. Take these, you can copy and paste them if you want to, drag them over here. Now I'm going to highlight my data. So click, hold, and drag so that all my data is here. You can retype this however you want to do it. I'm going to go over here to the Insert Chart button, click it, and there you go. That's my line. That's the graph that I'm looking for. I can copy and paste this. Right click or Control C, go in here, Control V, just paste on link. There you go. There's the picture. All right, if you have questions, please ask them, email me, or come in during office hours onto Google Meet and ask them then, and I'm happy to help you.